welcome to the first module of this International Diploma in Occupational Safety and Health. Today we are going to deal with the introduction to safety management. Basically in this unit, we will be covering the fundamentals of safety management. Some of you may be familiar with the terms, terminologies, etc. But to start a program, initially we have to discuss certain fundamental aspects. So this element, I am going to focus on the basic fundamentals of HSE management as a class. First, let us read this very beautiful words. Safety is not an intellectual exercise to keep us in work. It is a matter of life and death. It is the sum of our contributions to safety management that determines whether the people we work with live or die. This was told by Sir Brian Appleton. There is very meaningful words. Each one of us should keep it in heart. So with that, let us enter into this introduction element. Workplace safety. See, whether a project or an organization should be run with safety or without safety, that is a decision to be taken by the management. And management do take this decision based on certain influences. Maybe one type of management, they understand the value of human life, human health. They want continual improvement of the organization. So they support safety and they give the first priority for safety than the completion or the project. Another school of management thought, they willingly implement safety just because the legal enforcement systems are very tight. They don't want to take a chance with the enforcement actions. And the third class of management, they are well understanding that unless they carry out the job with safety, their ultimate aim of continual growth as well as profit cannot be achieved without supporting the safety systems. So whether to implement safety in a workplace or not, ultimately the decision has to come from the management side. As I always tell, safety needs two things basically. One is attitude and other one is money. The first requirement is attitude and the second is you need money to run safety. The same thing we can call in corporate world, the attitude is nothing but management commitment. And the money we call it budget. Unless a management gives us their commitment to implement safety and they allocate adequate budget for safety, implementing safety will not be possible. So whether to give that commitment and give that budget, the decision has to come from the management side because they are the owner of the project. Now let us discuss two types of business thoughts. As you all are aware, any business is basically oriented towards making profit. There is no doubt in that. If it is not making profit, then it is a charity. So ultimate aim of any business or any activity, business activity in this world is to earn a profit. And the profit can be earned in two ways. How you are going to get the profit depends on the vision of the management, depends on the commitment of the management, and this vision can be two types. Here I am showing you two types of graph on this screen. Towards my left side, you can see a graph. Now, what is this graph? I will just explain you. This one, what you see, x-axis, we can take it as number of years. Or let us say okay. Let us start with this x-axis. This x-axis shows you a number of years a company is formed. Suppose, for example, this company is formed in 2010 and now it is 2019. So there's a growth of maybe it's like the company started in 2010 and it is now 2019, and this curve which shows, this shows the growth of the company, and this y-axis is profit. Let us say in terms of lakhs or thousands or lakhs, 1 lakh, 2 lakh, 3 lakhs, 4 lakh, 5 lakh, 6 lakh, like this. This shows the profit. So this company, let us name it as organization A, and this one is organization B. The aim of this organization A is making money than anything else. So they have very less cooperation, they have very less thought about implementing safety management systems. Obviously, since the vision of the management is making maximum profit, you can see they are achieving high level of growth. Every year they are achieving growth. But when you see this company B, they also started in 2010 and now it is 2019. But their growth, they are also growing, but they have not reached up to that level where the company A has reached. So you can see there is a gap in the profit range. It's not that they are going in loss, but they have not gained as much profit as company A has gained. What can be the reason? If you see here, this organization B, the growth in times, you can see there are certain steps. You can see these steps, due to which their growth is slightly lesser comparing to, and here you see there is no such steps. There is no such steps. So why did this management take these steps, some time to grow, some investment in between, back investment? Because this company aims to achieve, what you can see is this continual growth. This company aims to achieve continual growth. But for this company, only profit. They are only profit-oriented company. They want only profit. So they don't mind about these steps. Now, what is these steps? These steps are called standardizations. or we can call rather business standardizations. Now, what are business standardizations? As you all know, if you want to run an organization towards achieving a continual growth, the organization must be strong. Strong enough, like a pillar. Suppose you are constructing a pillar. Say for example, let us come here and let us go for a pillar. See, this is a pillar. Suppose you construct a pillar for a house or a carport or something. Now, there are two types of pillar. You can buy a ferro constructed molded pillar from the market. From inside it will be hollow, but outside it will look as a pillar. Or you can go for a concrete RCC pillar using proper iron rods, cement mortar, metal in the right combination, right curing. So choice is yours. Whether you go to outright to the market and buy a molded pillar, you can save time, you can save money and effort. When you go for a concrete pillar, you have to put more time, more money and more effort. But ultimately you know inherently which pillar is stronger. The molded pillar will not have the strength to bear the shock or any external shock which the RCC pillar would have. So this growth is something like molded pillar, and this growth is the RCC pillar. So which growth you need, the management has to decide. Here it is quick growth, because you are not doing any standardization, you are not investing any money back into the system, you are taking all the money to the bank, so your profit record shows continuous growth. Whereas this company B, their vision is slightly different. They are not only profit oriented, they want profit, but at the same time they want to be the market leaders. They want to become a brand. They want a continual growth and the sustainable growth. They are looking for a long-term vision and sustainability. So they have to do standardizations. They have to go for the RCC pillar, which I call standardization. So first they go for, as you know, any business depends on quality. You may be a construction owner, you may be a process owner, you may be a service owner. Your continuity in the business, your position in the business field depends on the output, or rather the quality of the output you deliver to your customer. Because what you say in simple as quality, otherwise we can say value for money. Unless you give value for money to your customer, you cannot keep the customer, retain the customer. There will not be any word of mouth reference coming back to you. Your business will struggle. But if you give quality, if you give value for money to your customers, they will be happy. They will refer your business to other customers. Your business will multiply, so forth and so on. So you reach continual growth. So the first quality standardization which is required is quality standardization, which we go for QMS. You all know that is nothing but quality management system. So standardization is achieved only through implementing systems. What is the difference between a normal operation and a system operation? A normal operation depends on man. A system never depends on man. A system is a collection of set of procedures. Man can change, procedure will not change. So once you implement certain procedure for standardizing the quality of your product, each and every product coming out of your organization will be quality assured. Rejections will come down. Customer satisfaction level will go very high. So you achieve quality standardization for continual growth of the organization, which we achieve by following ISO The system is ISO 9001, as you know, maybe 2015. So you follow this standard. The standard is ISO 9001, and the specification which you follow, it is immaterial which specification you follow, but you always go for upgradation. So this first number you see 9001, that is the standard number, and the 2015 is the specification number. Similarly, you go for the first, you standardize the quality, right? You are achieving quality in your product, good. But now it is time for you to set an establishment a standard for environmental management system, because you need sustainable growth. You cannot grow as an organization by spoiling this environment. Your business cannot spoil this environment, because there is a government regulation, there is a public requirement. So you cannot sustain in this market by polluting the environment. So definitely you need a system to ensure that you don't pollute the environment and you are doing a sustainable business. So you go for EMS, Environmental Management System. We have this ISO 14001, whichever specification you use, that doesn't matter. But this standard will not change, that is ISO 14001. Then, so your environmental standardization is done. You are not spoiling the environment now because you have a system. But definitely these two systems, generally people give more thought because they drive business, they bring business. But these are not the only two systems on which your organization can grow. If you really want to achieve continual growth for the business, you must standardize your safety. So you go for HSE management system. Till now, we were using the OSAS. OSAS. What is OSAS? You know, Occupational Health and Safety Assessment Series. Don't confuse with OSHA. OSHA is different. This is Occupational Safety and Health Administration. That is a department of the US for implementation of safety in the United States. Occupational Safety and Health Administration, they develop safety standards, they publish safety standards. But this is OSAS. OHSAS means Occupational Health and Safety Assessment Series 18001. This is what we used to use, and still some of them are using it. So guidelines for implementing HSE management system. But now we are migrating to the ISO standard, that is 45001. So you all know it was started in 2018. And 3 years period, within a 3 year, this OSAS 18001 is going to be obsolete and we are going to migrate to ISO 45001. So for professionals, you are well aware of what is these systems, but if there is any beginner for him, see, these are the standards for getting standardization. In other words, you can say they are the guidelines. Suppose I have an organization, in my organization I want excellent quality for my products. I just need to follow this 9001. There are some requirements and guidelines. Say for example, you have to have a quality policy. You have to have a quality department with a hierarchy, duties and responsibilities, organizing, planning and implementation systems, feedback and evaluation. So all that is taught to you, is given to you in a printed notes, as a manual, as a guideline, which you can just implement in your organization. That is what is these guidelines are all about. It's 9001, 14,000. So if you implement 9001 guidelines, you are achieving quality management system standardization. If you are implementing 14,001 guidelines, you are achieving the environment management system standardization. If you implement ISO 45,001 guidelines, you are achieving HSE management system. Now this is slightly changed to OHS and SMS. OH, occupational health and safety management system. OH and SMS. This is what is now going to come. OH and SMS. That is going to be the new system going to come. So we have by now discussed about the standardization. I hope you understood. So again telling you, the first standardization is quality management system. The second one is the environment management system. There is no order and preference and priority. I just follow the sequence in which generally the management follow, because the quality and environment, as I said, business requirements, and more of the management consider HSE as a legal requirement. So naturally that order I followed, that is the order I followed. And I have even in my experience seen management giving more support for quality systems, environment system, but when it comes to HSE systems, they generally put one foot back. But if a learned management, a management who knows really the value of safety systems and procedures, they will definitely put this one first. They will go for HSE management system. And I have even experienced some of the management telling in every meeting and every interaction, safety is our priority. Yes, there are few managements who really, without any class or without any coaching, they have agreed and they are in principle following that safety should be the first priority in any operations. It's also there. It's not that every management is giving second thought of safety. Yes. So predominantly you will see we have to prompt. We may have to make them understand what is the importance of safety management system. So now, what is the difference between these two growth? Here there is no system. There is no procedure. They only believe in profit. They're taking all the money to the bank. There is no quality management system. There is no environment management system. There is no safety management. Now what will happen? One fine day, if something happens at this stage, the entire organization is going to collapse. But if something happens, maybe due to some market correction or something, some fringe accident, this is going to come only up to this level, because these steps are there to hold the shock. That is why management invests huge amount of money and develop quality management systems, environment management systems and safety management systems. So it will not come down all the way to the 0 point. So these steps will absorb the shock and they act as like a shock absorber to the system. So whichever management understand this, they will definitely support safety systems. Okay, now let us proceed further. So I hope you understood. Till now I was explaining what is the importance of something called business standardization. Business standardizations. These are all your quality management system, your environment management system, and your HSE management system all comes in business standardizations. So only through these standardizations, a company can achieve what is called continual growth. And continual growth is this growth, not this growth. This is only making money. So every organization which aim for a sustainable business, to be a market leader, to achieve phenomenal growth in the industry, to be a brand, definitely they will follow this model, the continual growth model. So that is where this system is very, very, very important, because even if somewhere you lose the quality, you can make up. Maybe we can give replacement, we can go for replacement by which we can retain the customer. Recently, I purchased an item. It's nothing but it was a gas stove, for which I give more priority because since I am dealing with safety. But it developed, and it was, I will not tell the brand, but it was a very high quality. The brand is known to be of high quality brand. So I went by that brand, but unfortunately, that item developed a snag, and it repeatedly developed snag for 3 to 4 times, and then finally I wrote to the company, this is a gas stove, and for which you have to give most priority to safety, and now I cannot go further snag rectification, because already 3-4 times you have done it in a span of 2-3 months, and you have to replace it. So immediately they said sorry, and they have replaced the item, and now I got a brand new item and it's working fine. Okay, I am happy. But if there is one accident on the site, and that one accident will be the end of it, you cannot replace. Just think about Union Carbide, which created the accident, the plant of the Union Carbide which developed the Bhopal gas tragedy. You say one accident, finish. The entire organization is finished. The entire business is finished. So unlike quality where you have a replacement option, here you have any environmental pollution, yes, we can compensate, but you cannot compensate a major accident. Your business is gone. So a management who really understand this, the effect of an accident, they give first and top priority they will give to safety management system. And my experience, if your safety management system is robust, excellent, all other management systems will fall in place. They will automatically become excellent. So the topmost priority must be given for safety management system. So I hope by now you got an idea why an organization should give more priority to implementing a safety management system. Next, we are going to go for a case study. Since I have just now given you an idea what happened to the organization Union Carbide after the great Bhopal tragedy. Actually, it was a very unfortunate incident towards the humankind or mankind. When this industry started in India, actually the people of Bhopal thought about prosperity, development. They thought Union Carbide definitely bring us jobs, development of the entire area called Bhopal, and also bring prosperity to the country as well as people. Yes, they were definitely a brilliant organization. They had very good systems, procedures, and everything was good. But unfortunately, finally it ended up in a great tragedy. So let me go through it. The accident history. On 3rd December 1984, this accident happened. So let me give you a pen picture of the history of Union Carbide in India. During the late 70s, India was facing a famine. Food production went down. The Green Revolution was to be started. There was a recommendation that we should go for introduction of pesticides in farming because most of our food products are destroyed by the pest. So at that time, a global tender was initiated, and the tender went for Union Carbide, which was a phenomenal organization having expertise and experience in making pesticides, chemicals. So naturally they got the tender and they came to India, set up an excellent plant in Bhopal. They had every system in tune with American standards because it's an American company. The operations was going good. They set up the plant, and this organization was considered to be the number one organization in India at that time. People, the young generation at that time wanted to get a job in this organization. It was considered to be a prestige to work with Union Carbide. That was the level of this organization. But unfortunately, their sales or their marketing of the product, the pesticide, did not pick up as was planned by them. What I am discussing here is based on certain theories which I have gone through, certain case studies which I have gone through in my studies as well as my research on this particular accident. Once the sales was not picking up, the management wanted to cut overhead cost to balance between the cost and the revenue. So they did a study on which all the area they can cut cost. So each departmental head was supposed to submit a report in his department which area cost can be reduced. So it was given to understand the supply chain brought an idea. There is a gas called MIC, methyl isocyanate, which is imported on a scale of 500 kg on each consignment. Why? It is an international convention as per the COSH, Control of Substances Hazardous to Health. MIC is a highly toxic chemical. It should not be stored more than 500 kg. That was the real point. But the supply chain management gave an idea. Since this is a required ingredient for our production, why not we go for a large consignment? This idea was negated by the safety head. The safety department head has warned the management, no, please don't do this, because the allowed quantity of storage is 500 kg only. But obviously, cost cutting got succeeded. At the time of the tragedy, the tank in which the reaction took place between water and I will be just discussing the story also. It contained 40,000 kg of MIC, one tank. 40,000. Instead of 500 kg, the tank contained 40,000 kg of MIC. And just imagine, that is where the fatal mistake has been done. And that is why this much amount of casualties resulted in this accident. So how the accident happened? There were deficiency in safety systems due to the cost cutting. It was given to understand that this plant, they used to do flushing of the pipelines off and on to clean the system, and flushing is done by water. As you can see in the picture, there is a maze of pipelines in this organization which they do flushing. So in normal case, see, there were some maze of pipelines like this. So these pipelines were flushed with water, high power high pressure water is injected, and there were two outlets at the far end. The first outlet, and this is the second outlet, through which the impure water will go out. So during the design safety people, they knew that in case of a blockage to this outlet, okay, there is a standby outlet, but even if this block, because these are bringing the impurities, there is a chance that this water is going to circulate in wherever possible way, and this is going to end up and going to reach the methyl isocyanate tank. This is MIC. The water is highly reactive with MIC, methyl. And you know, this is a pressure is a gas. MIC is a gas, and if water react with the gas, naturally pressure is created, and there will be rupture of the tank or leakage of the tank. And MIC is highly toxic. If people inhale, their respiratory tract will be damaged, blood will flow into the lungs, their lungs will quench in their own blood, and they die because of asphyxiation. That is the highly toxic gas, this MIC. So they, in the design safety study, they have recommended that there should be a flange somewhere here, a flange. You know, a flange is to block this pipe. And there was a SOP, standard operating procedure or safe operating procedure, which told before starting the flushing here, this flange should be put. This is not for normal case, but this was for the special case. If this pipeline block, then water is going to come all the way down, and that time they want this. So that is what they don't want. So on this day of 3rd December 1984, actually the action started 2nd December. 2nd December the flushing, I think at around 8:45 in the night, they started flushing. At around 11:45, the night of 2nd December, the first outlet got blocked. And at 10:12 in the midnight, the second outlet also got blocked. And when the water went into this place where there is the flange supposed to be, the flange was missing. That flange which was supposed to save the people was missing. And this leakage of water into the MIC tank, you can see the leakage of water to the MIC tank. Why? Because, as I told you, there was a flange in the pipeline which is coming to the MIC. This flange was missing. This flange was not there. Why the flange was not there? Again, investigators investigated. Some of the maintenance workers thought this is waste of time, because to remove some 11 bolt, putting the flange, tightening the 11 bolt, after flushing, coming back, again removing the 11 bolt, removing the disc, again putting the bolt. It took around 3 hours of time. So they bypassed. Because in normal case, nothing is going to happen. They have never experienced such a mishap. So they took it for granted. Maybe lack of supervision, bypassing systems and procedures due to they have bypassed all the safety procedures, which we will be discussing later. So this missing of this flange has caused the whole Bhopal tragedy. If the flange had been there, the Bhopal tragedy would not have happened. This is why it's a simple flange. It's a simple safety procedure which is bypassed, killing thousands of people, destroying the entire Union Carbide into ashes. So this leakage of water into the MIC, you can see here, this leakage of water into the MIC tank caused the increase in temperature and pressure of the MIC and release of 40,000 kg of MIC. Had it been 500 kg, as directed by the cost regulation, the effect would have been much lesser. But here it is, they violated that, they stored 40,000 kg in that particular tank. So the effect was phenomenal. 2,500 people died immediately. 8,000 more died later due to picking disease. More than 5 lakh people were affected directly or indirectly. Still the compensation issue is going on. More than 750 billion US dollars compensation is going on. Just imagine why it happened. Why it happened? Safety procedure. You are bypassing the safety procedure. Just because you bypassed the safety procedure, not following the safety systems, not following the safety directions, this has happened. So this is a big case study we should all think about. You can see here, this picture shows strewn bodies all over aftermath of this Bhopal tragedy. Hundreds of thousands of people died. The reasons or the major causes are storing MIC in large quantities beyond recommended level, failure of safety systems. There were safety systems, but they failed. Cost cutting by compromising the safety systems. You will be astonished. You will be astonished to know that there were safety systems, but they all failed. Why it failed? We will discuss it. There was when the MIC entered into the tank and reacted, it generated a lot of heat. So there was a cooling system to cool the tank. And they used the freon to cool the tank. But on that particular day, the freon was missing. That freon was drained and taken to some other plant for some other operation. And to cut the cost, they took this freon from the cooling system of the MIC tank to some other plant. So the cooling system failed. Secondly, there was a flare tower. You know the flare tower to burn off the gas. But a connecting pipe to the flare tower was removed for maintenance and it was never fitted back. Violation number 2. Thirdly, there was a vent gas scrubber system. Vent gas scrubber system to detoxify the gas. But the scrubber was turned off. For what reason? They know. There was a water curtain to arrest the spread of the gas, but the height of the curtain was very less. So the gas exceeded the height of the water curtain and it spread to large area. You see, there were more than 3-4 systems, safety systems, and nothing worked on that day. Apart from that, why? You can see this cost cutting by compromising safety systems. Adding to that, there was lack of skilled labor and there was also inadequate emergency action plans, which resulted in this biggest tragedy in the history of industrial safety. Similarly, now we will see a video on this tragedy to make it more understandable.
People of Bhopal, capital town of the Indian state Madhya Pradesh, were sleeping through a cold intervening night on 2nd and 3rd December 1984. Nothing was out of the ordinary, and the night seemed like any other silent shivering winter night. But that was only superficial. Somewhere in the eastern part of the city, something nightmarish was happening inside a pesticide plant of the Union Carbide India Limited, or UCIL. An industrial disaster of incomparable magnitude was about to happen. The UCIL plant was established in 1969. 51% was owned by the Union Carbide Corporation, or the UCC, and 49% by the Indian authorities. The factory used to produce a pesticide, which UCIL had branded as 7. A chemical called methyl isocyanate, or MIC, was used for producing this pesticide. Therefore, the factory stored a large amount of MIC inside its premises. On that fateful night, on December 2, 1984, it was a routine day at the UCIL factory in Bhopal. MIC was stored in the underground tank. The pipeline washing started at 9:30 p.m. as a routine maintenance operation. Between 10:30 and 11 p.m., workers engaged in the pipeline washing became aware of a leak. Little attention was paid considering it a normal leak. A casual attempt was made to trace the source of the leak, but of no use. The leak continued. Around 12:15 a.m., the pressure in the MIC tank rocketed up to 55 pounds per square inches. Water had begun to leak into the tank E610, containing 42 tons of MIC. The resulting exothermic reaction increased the temperature inside the tank to over 200 degrees Celsius. An operator saw the concrete above the tank was cracking. About 12:30 a.m., the relief valve of the tank gave away, and large quantities of MIC gas leaked into the atmosphere. The workers at the factory realized the risk of a massive disaster. They tried activating the safety systems available at the factory. There were 3 safety systems. First was the vent gas scrubber, which was considered the main line of defense. It was found that it wasn't in operational condition. Then the workers tried turning on the flare tower to burn off the toxic gas. This system was not in a working condition, as the piece of pipeline leading to the tower had been removed for maintenance. The workers then tried transferring the MIC from the tank into a nearby spare tank. The gauge of the spare tank indicated that the tank already contained something. This gauge indicator was found defective later on. After failure in all 3 safety systems, the workers attempted to douse the leaking gas with a water spray. The water spray reached a height of 100 feet from the ground, while the leak was at 120 feet above the ground. At 1 a.m., the workers realized nothing could be done to stop the leak. Thousands of people living around the plant were awakened by suffocating, burning effects of the gas. As on the 3 sides, the UCIL plant was surrounded by slums and other poor settlements. The people living in these colonies were the worst sufferers. There was no warning or guidance to the general public around this time. There were 2 types of alarms in the factory. One mild siren for the workers and one loud public siren. The public siren was started only at about 2:30 a.m. and since the gas leaked from a 30-meter chimney, it wasn't high enough for the people to escape the effects. It was not long before the entire city was enveloped by an invisible but extremely toxic gas. People of Bhopal began to feel the effects of toxin. People who were laying cozily inside the duvets a few minutes ago, they now began to feel suffocation, cough, burning eyes, and vomiting. Streets began crowded with people running here and there for help. The chaos went on through the night. Local hospitals were soon overwhelmed with the injured, a crisis further compounded by a lack of knowledge of exactly what gas was involved and what its effects were. Within hours, the streets of Bhopal were littered with human corpses and the carcasses of buffaloes, cows, dogs, and birds. About 3,000 people died immediately on that night. Another 8,000 died in the next 1 week. Yet another 15 to 20,000 people died over a longer period of time due to the effects of the poisonous gas. Still, about 500,000 people were directly or indirectly affected, with 38,000 temporary partial and roughly 3,900 permanently disabling injuries. Investigations into the tragedy show that there were many shortcomings at all levels. The Union Carbide factory did not have much information about the safe storage of these highly toxic gases. The medical fraternity did not have the requisite know-how to deal with such kind of contamination and at this scale. There was also a lack of coordination between the factory and the emergency services. There were not many trained professionals in that factory. Cost cutting had also had its impact on the safety of the plant, its employees, and the people living around the plant. The plant was also in a densely populated area of the city, which went against most known norms. There have been several theories on the reason for the entry of water into the tank. The workers claim that because of the bad maintenance with leaking valves, it was possible for water to climb from the point where the pipeline washing was performed to tank 610, while UCC says that this was not possible and that it was an act of sabotage by a disgruntled worker who introduced water directly into the tank, although there has never been any proof of this. The two most important factors leading to the mega gas leak were the plant design and the economic pressure and the cutting back on. There were early warning signs of trouble ahead, signs that may have been ignored. On December 25, 1981, a leak of phosgene killed one worker at the plant and severely injured two others. On January 9, 1982, 25 workers were hospitalized as a result of another leak at the plant. During the safety week proposed by the management to address worker grievances about the Bhopal facility, repeated incidents of such toxic leakage took place, and the workers took the opportunity to complain directly to the American management officials. In the wake of these incidents, workers at the plant demanded hazardous duty pay scales, commensurate with the fact that they were required to handle hazardous substances. These requests were denied. As a result, it led to the worst industrial disaster of all time. On December 7, 1984, Warren Anderson, the CEO of Union Carbide, was arrested in Bhopal, but later released on bail. In December 1987, the Central Bureau of Investigation filed a charge sheet against Anderson and other accused. In 2003, the Ministry of External Affairs sent a request to United States for Anderson's extradition. However, this and further requests were turned down. In June 2010, 7 ex-employees, including the former UCIL chairman, were convicted in Bhopal of causing death by negligence and sentenced to 2 years imprisonment. An 8th former employee was also convicted, but died before the judgment was passed. A compensation of nearly $470 million was paid by the Union Carbide to the Government of India, but legal delays, including identifying the victims, slowed the payout rate to a crawl. The only memorial ever built in Bhopal was privately funded, designed by the daughter of Holocaust victims. In bold letters, the inscription reads, "No Hiroshima, no Bhopal. We want to live." Many years down the road, after the Bhopal disaster in 1984, some basic cleanup efforts have taken place, but a lot of contamination is still there, and the local people have to live with this environmental pollution every single day.
A recent accident to be discussed is the DeepWater horizon. Some of you may be familiar with this. It happened on 20th April 2010. There was explosion and fire which killed 11 workers. It was on an American offshore platform. Massive oil spill in the Gulf of Mexico. Largest oil spill in the US history. And the major causes, poor safety culture. American agencies have conducted a very deep study because more than 11 workers were killed on the platform, and gallons and gallons of oil spread over this sea, killing flora, fauna, and many other species. It was basically they identified that there was a poor safety culture. Rush to completion. There was a rush to complete a task. Poor management decisions as well as design flaws were there in the system. All this contributed to this explosion and fire. Naturally, we will see another video on this.
April 20th, 2010. 11 workers died and 17 were seriously injured by an explosion on the DeepWater horizon, an offshore drilling rig located approximately 50 miles off the coast of Louisiana. The rig burned for 2 days, eventually sinking and triggering the largest oil spill in U.S. history, as oil and gas spewed up from the sea floor. The DeepWater horizon had been drilling an oil well in 5,000 feet of water in an area of the Gulf of Mexico known as the Macondo Prospect. In 2010, the CSB launched an investigation to examine the technical, organizational, and regulatory factors that contributed to the accident. During the investigation, the CSB made new findings about why a key piece of safety equipment, the DeepWater horizon's blowout preventer, failed to seal the well during the emergency. These new findings help explain why the accident was so devastating, and the CSB cautioned that other blowout preventers currently in use could fail in similar ways. Drilling an offshore well involves creating a pathway between the drilling rig and oil and gas reservoirs trapped beneath the sea floor. A deep hole, or well bore, is drilled through layers of subsea rock and sediment. These rocky layers can contain trapped water, crude oil, and natural gas under pressure. An unplanned flow of these well fluids into the wellbore, known in the industry as a kick, can be dangerous. Without careful management, a kick can lead to a blowout, the uncontrolled release of flammable oil and gas from the well. A blowout can be catastrophic, since oil and gas reaching the drilling rig can quickly find an ignition source, leading to a fire or explosion, endangering the lives of the drilling crew. To prevent kicks, drillers pump a dense slurry called drilling mud into the well, creating a barrier between the undersea oil and gas and the piping that leads to the rig. If this mud barrier fails or is somehow removed, the safety of the drilling crew depends on a critical piece of equipment located on the sea floor called the blowout preventer. or BOP. The BOP is a complex electrically and hydraulically powered device that is essential for controlling the well and, in an emergency situation, preventing a disaster on the platform high above on the sea surface. The BOP is connected to the rig by a large diameter pipe called a riser. If a kick occurs, the blowout preventer is designed to prevent flammable oil and gas from traveling up the riser to the drilling rig. This is done by sealing the area around the drill pipe, known as the annular space. To do this, the crew can manually close pipe rams and donut-shaped rubber devices known as annular preventers. If those devices should fail to work, the last resort is a pair of sharp metal blades which form a blind shear ram designed to cut the drill pipe and seal the well. The blind shear ram can be activated manually or by automated emergency systems. At approximately 8:45 p.m. on April 20th, 2010, a kick occurred in the Macondo well. Oil and gas entered the well bore undetected, eventually passing above the blowout preventer and traveling quickly up the riser toward the deepwater horizon and the 126 people on board. Just after 9:40 p.m., drilling mud, forced upwards by the rising oil and gas, suddenly blew out onto the rig. Crew members responded by closing the upper annular preventer in the BOP. However, this did not seal the well as intended, and flammable oil and gas continued to flow into the riser toward the rig. Next, the crew closed a pipe ram. This successfully closed the annular space and sealed the well, but tragically this proved to be only a temporary fix. Oil and gas that were already above the pipe ram continued to flow inexorably toward the deepwater horizon. At approximately 9:49 p.m., the flammable hydrocarbons found an ignition source, and the first explosions shook the deepwater horizon. As the oil and gas escaped the riser onto the rig, the pressure dropped in the annular space above the pipe ram. But at the same time, the pressure in the drill pipe climbed substantially. The drill pipe was closed at the top, but oil and gas continued to flow in from the reservoir below. After extensive analysis, the CSB concluded that this large difference in pressure likely caused the drill pipe to buckle, essentially bending the pipe off-center inside the blowout preventer. The buckling pushed sections of the drill pipe outside of the reach of the blind shear ram blades. This would eventually prove to be catastrophic. With the drill pipe buckled, the explosion and subsequent loss of electrical and hydraulic power from the rig likely activated an automated system on the blowout preventer known as the AMF deadman, which closes the blind shear ram and cuts the drill pipe. This emergency system is designed to activate when electric power, hydraulic pressure, and communications from the rig have been lost. The AMF deadman system was operated by two redundant control systems on the BOP, known as the yellow pod and the blue pod. The redundancy is supposed to increase the reliability of the system in an emergency situation. The yellow and blue pods worked independently of each other and were comprised of identical enclosed computer systems and sets of solenoid valves. When activated, the solenoid valves controlled important BOP functions, such as closing the blind shear ram. If electrical power from the rig was lost, as happened on April 20th, 2010, both the yellow and blue control pods contained backup 27-volt and 9-volt batteries to power emergency functions. The 9-volt batteries powered computers that would activate the solenoid valves, which were powered by the 27-volt batteries. However, evidence indicates the blue pod had been miswired at some time before the BOP was lowered onto the seafloor. This caused the pod's 27-volt battery to drain and made it impossible to operate the solenoid valve for the blind shear ram on the night of the accident. And within the redundant yellow pod, the solenoid for the blind shear ram had been miswired. The solenoid valves were controlled by two coils of electrical wire. These two coils were designed to work in concert, generating a magnetic field strong enough to operate the valve. But within the miswired solenoid valve, the two coils actually opposed each other, leaving the valve paralyzed. Only a third unplanned failure allowed the yellow pod to operate. On the night of the accident, one of the 9-volt batteries that powered the solenoid valve's computer had failed. As a result, the affected computer system could not initiate the command to energize the miswired coil. Had both coils of the miswired solenoid valve been energized, the two coils would have generated opposing forces on the valve. The solenoid valve would have remained closed, and the blind shear ram would never have been closed. However, the failed battery rendered one coil inoperable, and most likely allowed the other coil to open the solenoid valve by itself. This in turn initiated closure of the blind shear ram. This should have cut the drill pipe and sealed the well, greatly reducing the impact of the accident. But because the drill pipe was buckled and off-center inside the blowout preventer, it was trapped and only partially cut. With the failure of this last-ditch measure, there was nothing left to stop the massive oil spill and the destruction of the rig. During its investigation, the CSB identified a mechanism that likely caused the drill pipe to be buckled around the time of the explosion. This mechanism is called effective compression. Although effective compression had previously been noted as a hazard in other drilling operations, it had never been identified as a problem affecting drill pipe during well operations. Effective compression occurs because although pipe may appear to be perfectly straight, in fact it has minute bends and irregularities, invisible to the naked eye. Along these bends, the side of the pipe that is curved outward is slightly longer and has more surface area than the other side. When there is a large difference in pressure between the inside and outside of the pipe, as happened on April 20th, 2010, the longer side of the pipe experiences a larger bending force. Eventually, this force can become great enough to buckle even heavy pipe. This is an important finding, CSB investigators said, because the same conditions of differential pressure could occur at other drilling rigs, even if a crew successfully shuts in a well. The CSB warned this could make existing blowout preventer designs less effective in emergency situations. In the case of the DeepWater Horizon accident, the buckled drill pipe prevented the blind shear ram from sealing the well. Oil and gas from the well flowed out of the buckled drill pipe and into the Gulf of Mexico for 87 days. A reported 5 million barrels of oil eventually spilled, causing one of the worst environmental disasters in United States history.
So, by seeing these two videos discussing on these reasons why these things happen, I hope I need not to emphasize that every management should take safety as the first priority in every operations, because one accident kill the business, kill the reputation, and big legal actions will follow. So never to compromise on safety in any aspects of your operations. This thought process has to go into the mind of the managements, and it should reflect in their commitment and vision towards implementation of safety systems in their organization. So what is safety? Many explanations, meanings. If you see dictionary meaning is freedom from risk for safety. A state or status of a system in which all business related risks are at an acceptable level. And safety is mainly related to unintentional accidents, incidents and losses, whereas security contains the aspect of intentional damage, crime and terrorism. Since security also is an important aspect of safety, I wanted to clear it. What is the difference between safety and security? So I hope these three meanings of safety clears the term to all of you. Now let us see what is safety management. Safety management combines different sectors of safety as one entity and thus functions as a coordinator between the sectors. It combines different sectors and make it as one system or one entity. Safety management combines the management of methods, practices, and human resources. It consists of continuous planning, action, and follow-up, which later we will be studying as plan, do, check, and act. Obviously. Safety management includes both anticipatory as well as remedial action in order to continuously improve the working environment. So, for any management, we need a system. Like in the first part of this module, I explained you quality management system, environment management system, and HSE management system. So that is what is this we are discussing is the safety management system. What is a safety management system? It is a systematic, explicit, and comprehensive process of managing safety risks. It's a process. It's a combination. Safety management system provides for goal setting, planning, and measuring performance. We need to set goals. The management should be very clear. What is my safety goal? What is our vision about safety? They should be very clear. Then they should plan for achieving that vision. And it is done through proper planning, execution, evaluation, and finally, measuring the performance and improving the performance in safety sector. It is a management system or part of a management system used to achieve the occupational health and safety policy. That is what is the definition as per the ISO 45001. What is a hazard? Hazard is something with the potential to cause harm. It is a source with the potential to cause injury or ill health. Hazards can include sources with the potential to cause harm or hazardous situations or circumstances with the potential for exposure leading to injury and ill health. This ill health, very important. Similarly, risk. What is risk? It is nothing but effect of uncertainty. Obviously, the effect can be positive or negative. And the risk we evaluate using a formula that is likelihood into severity. What is the likelihood of an occurrence and multiply with what will be the severity if that happened. OHS risk is a combination of the likelihood of occurrence of a work-related hazardous event or exposure and the severity of injury or ill health that can be caused by the event or exposure. So, we evaluate the risk. Why? Because we need to classify it as high risk, medium risk, and low risk. So, how we classify is based on this value which we get when you multiply the likelihood and the severity. So, here we are not going deeper into the calculation part, but which we will be doing later. Here we are only dealing with the terminologies. What is risk? Now, what is the relationship between incident, near miss, and accident? More conflicting word, this incident. The name incident, a lot of controversy is there over that, but we will clear it now. See, you must know this word, that is occurrence. Occurrence. So there are two types of occurrences. One is desired occurrence and other one is undesired occurrence. Desired occurrence is what we think and we do it. But undesired occurrence, it just happens without any thought. So, if any undesired occurrence is called as incident. Yes. Any undesired occurrence is incident, and the output of this incident can be a no-loss situation or it can be a loss situation. That is where people confuse. See, an incident can result into a no-loss situation. If it does, it is called a near miss. If the incident result in a loss situation, we call it accident. That is a difference. So you must first understand what is incident. Any undesired occurrence, say for example, this batsman did not want to hit this person. He was just doing a batting and he wanted to score 4 runs. But eventually the ball fell in the path of this. It was undesired. It was undesired. But here, timely the fielder ducked and the ball missed the fielder. There is no loss. So this is a near miss. This picture gives a classic example for a near miss. If this ball would have hit this fielder, damaging his ribs or elbow, it should have been a loss situation. It would have been an accident. I hope it is clear to you. So an incident is any unexpected, undesired occurrence. A near miss is an unexpected, undesired occurrence from which there was no loss, and an accident is an unexpected, undesired occurrence from which there was a loss. What is continual improvement? In the beginning we saw the step-by-step growth of the organization is called continual improvement. Recurring activity to enhance the performance. Recurring activity. It is not quick. There is no shortcut to success. You have to achieve one at a time, one by one, step by step. Have patience. Have commitment. So it is a recurring activity to enhance performance. Enhancing performance relates to the use of the OHS or any other management system in order to, like EMS, QMS, in order to achieve improvement in overall OHS performance consistent with the OHS policy and OHS objectives. Once you are able to achieve it, your organization is achieving continual growth. Continual does not mean continuous. So the activity does not need to take place in all areas simultaneously. It can happen one at a time. That is why it is step-by-step achievement. What is competence? This word is very commonly used in safety, as we use this word quite often in safety. Competence. A worker must be competent. The operator must be competent. The scaffolder must be competent. The scaffolding inspector must be competent. Why? What is competence? It is the ability to apply knowledge and skills to achieve intended results. You may be familiar with this term, CATE. CATE is nothing but a competent person should have knowledge on the subject, K. He should have the ability to do the job, A. He should have got that knowledge through formal training, not by seeing or not by just because he has worked for 10 years, he does not become competent. If to become competent in a particular job, he should have attended some training and got a formal education and knowledge. Then only that knowledge will be counted as training for the competence. And finally, experience. The person should have experience on the job. Once a combination of all this is achieved, the person is called a competent person. Now, what is objective? Very important. For any individual to become successful, for any organization to become successful, we should have objectives, plans, visions, goals in our life, in the organization. So objective is nothing but results to be achieved. An objective can be strategic objective, it can be a tactical objective, or it can be an operational objective. We can set different objectives, because unless you set an objective, you never know where to go, and you never do a benchmarking. You don't know whether your performance is as per the requirement or not, or to the required level or not, what to do to improve the performance. You never know. So the basic requirement for growth is you should have objectives of growth. Objectives can relate to different disciplines like financial objective, health objective, safety objective, environmental goals and objectives, and also can apply at different levels: strategic level objectives, product level objectives, and process level objectives. So wherever you want growth, set objectives and go towards that objectives. That is what is called growth. Unless you have objectives, you are not growing. Now the objective for you, individuals attending this class, is to achieve international diploma in occupational safety and health. That is your objective. So you do well, you go through the study materials, you must complete this online course, and you should come and attend the classroom session, and then definitely you achieve the objective. Similarly, on your job, you may have your objectives. Generally, if you are given KPI, key performance indicators, make them as your professional objectives. The more you achieve these KPIs, your objective is satisfied. Your growth is guaranteed. So that is what is objective is all about. Now, who is interested party? A lot of questions are coming on this after this 45,001 guidelines have come out, because it has given a lot of emphasis on interested party or stakeholder. Many of the beginners may not be familiar with this term, interested party or stakeholder. A person or organization that can affect or be affected by or perceive itself to be affected by a decision or activity. Say for example, society. Society is a stakeholder. The society is going to be affected by the decisions management is going to. Let us come back to the Bhopal tragedy. The decision taken by the management to import a high level or the large quantity of methyl isocyanate impacted the life of the society. The society never expected that such a tragedy is going to happen to them. They actually expected the factory would provide them jobs, the factory would provide them infrastructural development for the village, the factory would provide them education, healthcare. As the factory grow, their lifestyle will grow, their development will be there. But in turn, the decisions taken by the management, directly or indirectly, affected the life of the society. So that is why society is definitely a stakeholder. So here in the PPT you can see very clearly it is given there. You can see that the company is affected by, or the company is directly affected by or affected to internal stakeholders as well as external stakeholders. So let us see who are these internal and external stakeholders. See, I told you some of the stakeholders are workers, legal authorities, parent company, and even the society. Here you have internal stakeholders as well as external stakeholders. So first let us see who are the internal stakeholders. The employees, the workers. Definitely they are going to be affected by and they are affecting the company. Similarly the managers, the owners of the organization, These are all some of the internal stakeholders. Whereas when you come to the external stakeholders, you can see the suppliers, society, government, yes, definitely, creditors, shareholders, as well as the customers. They are all the external stakeholders. So we will be studying in detail how these stakeholders are affected and how the stakeholders affect the company's performance and all that related. Just now, to make you familiar what is interested party or stakeholders. You can see in safety management, we do incident tracking, we do risk assessment or incident risk assessment, we go for employee training, employee qualification requirement, competency development, item tracking on actions and worksite inspections. It's all part of safety management. So, lot of this we are going to further discuss. This is only an introductory module. I hope you got a little bit of idea about what is going to come ahead. We will go very deeper into each and every concept of safety management systems, and definitely you will enjoy the program. We have I think number of modules we will have like this, and each module is going to give you a new idea, new thoughts by which you are going to elevate, update your knowledge. You are going to get not only brushing up the existing knowledge, but also you are going to get some new ideas and aspects of safety management in this course as we progress. So there will be one assignment, there will be a small quiz. I hope you will take it in a positive way and complete it before you proceed to the next module. Thank you for watching this and taking out some time to go through this module. See you in the next module. Bye.